Okay, so I'm gonna go over the fall semester study guide. I'll start with I'll only do one problem for each section. So for number 1, estimate the following solution of the following systems. If it says estimate, that means it's close to or approximate, and solution of a system consists of x, y. So in this case, if you look at chapter 1.5, we will see where the solution is, which is just where they intersect. So this is my solution. So this is my x. Sorry, I made a mistake over here. It should be x, y, x, and this is y. Sorry, here is y. So we start with x first. That's 2. My y is 2 as well. So 2, 2, because that is where they intersect. All right, that would be your justification, and here you would get 4 points. Number 2. So I'm only gonna go over one of them. I want you to see. Oh, sorry, I meant D. I'm gonna go over D. So for this one, we know, let me rewrite it. Y equals -1/2 x plus 8, 3x plus 2y equals 10. If you look here, remember, if you look at the steps, this is chapter 1.6, it says look for the isolated variable. We know y is isolated because it's the only one in the equal sign, on the other side of the equal sign. It's by itself. So that means we're just going to substitute. So we're going to substitute it to the y in this other equation. So I'm going to replace this y over here with this. Let's go ahead and do that. So I'm going to rewrite this one. So that's 3x plus 2 times -1/2 x plus 8 equals 10. Don't forget this 10 over here. 10 over here. Okay. Now, next step. So our first step was to substitute. Next step, we are going to distribute. So in this case, we have 2 times -1/2, 2 times 8. So let's bring down the 3x plus, since this is the same thing as my denominator cancels out here, and we are left with -1. Okay, so let me show you a side note for this. I'm going to use purple. 2 times -1/2. Okay, I will change the whole number into a fraction. Remember, if they have common factor in the top and bottom, they would cancel out, and I'm left with -1, which is this -1 right here. Don't forget to bring down the x, and then 2 times 8, which is 16, equals 10. Now our third step is combine like terms. Combine like terms. Which ones are my like terms? Right here. I can't combine 16 and 10 because there's always a line over here, a barrier at the equal sign. So we are left with 2x plus 16 equals 10. Subtract 16. We're left with 2x equals -6 divided by 2. x equals negative 3. Okay, that's only x. Now we have to find y. To find y, substitute x equals negative 3 to the first equation. So I'm going to call this 1 and 2. First equation. So my first equation was y equals negative 1/2 x plus 8. So I'm going to plug in negative 3. Y equals negative 1/2 times negative 3 plus 8. That equals, now our next step is to evaluate. This is going to be negative or positive. Negative times negative is positive. 3 over 2 plus 8. Let's get rid of the denominator. We multiply by 2. Everything by 2. That's 2y equals 3 plus 16. So that's 2y equals 19 divided by 2. Y equals 19 over 2. Okay, so these two would be your solution. So my solution is x equals negative 3 and y equals 19 over 2, or negative 3, 19 over 2. Yes, so this is my solution. Okay, to show your, so you guys have to show your work, and you just put the step by step. You don't have to justify using words. I mean sentences. I do want you to tell me your step process. You don't have to do complete sentences, just step by step process. Okay, next one, it says find the next 6 terms over here. Find the next 6 terms of each recursive formula. So the first one is done for you. This is found in 1.4. So my very first term, remember A1 means first term. Okay, so first term is 37. And remember, this negative 200 here is your common difference. Common difference, aka this is our pattern. So each time it'll be subtracting by 200. So 37 minus 200, I think we got negative 163. 163, and I'm going to keep subtracting 200 6 times. We are left with negative 363. I'm going to subtract by 200 again, and that is negative 563. I'm going to subtract another 200. That's negative 763, and then the last one is negative 963. All right, 1, 2, 3, 4, 5, 6. Yes. Okay, that's it. This is your solution. Your justification can be my first term, or according to the recursive formula, my first term is 37 and my common difference is negative 200. And then you just list this. All right, next one. Factor the following expressions. This one, we've done this so many times. So here, all you're doing is, the only justification you really need is, this is by difference of squares. Difference of squares. Okay, 9x squared minus 16. Right here is not our 3 and 3. And there's 2 x's. This is 4 and 4. A lot of you will say 8 and 8. Please. It is not 8 and 8. Okay, please double check your work. Your answer should be 3x plus 4, 3x minus 4, not 8. Okay, that's wrong. So your solution would be this, by difference of squares. Okay, you would just say since 9x squared and 16 are perfect squares, then by difference of squares, you do this. I'm gonna do this in two ways. The formula way, and then I'll do the simple way. I'll start with the formula. And then, or if you wanted the simple way, you can skip to the simple way. So here's a sports stadium, has 18 seats in the initial row, and each successive row has 6 more seats in the preceding row. If there are 8 rows in total, what is the total number of seats in the stadium? Okay, you guys have to read this carefully. It says there are 18 seats in the initial row. And what does initial mean? Initial means the very first one. And it says each successive row contains 6 more seats, meaning in the next row we will have 6 more seats. So how many will we have in the second row? We will have 24 seats. Right? So we have 18 seats. My A1 equals 18 initial. My successive row or second row has 6 more seats. So that is plus 6, which is my common difference. And there are 8 rows in total, meaning n equals 8. And we're looking for total number. So A1 is 18, right? So the next term, A2, would be 18 plus 6, which is 24. Right? But in the formula, we want to look for A8. So we use the explicit definition. So A8 equals, so explicit formula, first of all, is A sub n equals A1 plus D times n minus 1. So A1 is 18. My common difference is 6. My n is 8 minus 1. And if we use a calculator for this, we should get 60. So my last row contains 60 seats. Okay, and the next formula we will use is called a summation. Okay, summation here. So S sub n equals n times A1 plus an over 2. Now we just plug in these in this formula. So S, we're looking for 8, right? S8 equals 8 times my first term, which is 18, plus my last term, which is 60, divided by 2. So what is this? So we get 18 plus 60, which is 78 times 8, divided by 2. We should get 312 total seats. Okay, total number, that means addition. So this is the formula way. Now let's do Now let's prove that it's the same thing as adding every one of the problems, of the rows. So we start with A1, which is 18. A2, which is 18 plus 6, which is 24. A3, which is the third row, 24 plus 6, which is 30. A4, which is 30 plus 6, which is 36. And then A5 equals, well, obviously plus 6. So we're going to do that 42. A6 is 48. A7 equals 54. A8 equals 60. Okay, but now we know it's the same thing, right? With the explicit formula, A8 is still 60. Now let's add each one of these numbers. Here's an easier way to add them all, okay? What you guys can do, obviously, you guys can put all of these numbers in a calculator. All these numbers in a calculator, sure. Yeah, everybody can do that, but here's an easy way to do it so you guys won't get confused with the numbers. First, let's list out all the numbers again. 18, 24, 30, 36, 42, 48, 54, 60. Okay. And remember this at the very beginning of the school year, some of you guys added 1 through 20 and then 20 through 1 backwards, right? To get the same number for each one. So all I'm going to do here is I'm going to count backwards. So I'm going to do 60, 54, 48, 42, 36, 30, 24, 18. Okay, what happens if I add all of these numbers? Okay, if I add all of these numbers, I should get 78 for each one of these numbers. 78. And how many, so in total, how many 78s are there? There are 8 78s. So what's 8 times 78? That is 624. But that's not the total yet because we doubled everything. We doubled everything. So to get rid of this doubling, here, I am going to divide 624 by 2. So what is that? That is 312. So there are 312 total seats. So in order for you to justify this one for me, I want you to tell me what your first initial is. Make sure you use A1, initial, and your common difference. What's the common difference and how many in total? And that's pretty much how you would justify this for me. And obviously show your work. All right, 2.2, 10, simplify 15a cubed. Let's do number 10. Here's an easy way to do it so you guys don't get confused. Obviously, you start with the very first one. We'll start with 15a cubed minus 4a squared. And remember, distribute the negative. So first step, distribute negative. Distribute negative. So what is this? That's negative 7a cubed. Distribute the second one. Negative 2a squared. Next, distribute the third one. Negative 3a. Distribute the next one. That's plus 5. Okay, now let's add. Make sure that these are aligned, please. This is a to the third, this is squared, and there's no a here, no constant here. So now let's add vertically. This is just 5. 3a, bring it down. What's negative 4a squared minus 2a squared. That's both negative, so they add together, negative 6a squared. 15a cubed minus 7a cubed, that is 8a cubed. They're opposite signs, so you have to subtract. Okay, it's better to just align them like this so you don't get confused. Now let's do number 15. Number 15, we have 2x cubed, 2x plus 3 times 4x squared minus 5x plus 1. This is just multiplication. If there's no sign in between, it's multiplication. Multiplication. So, how do you multiply polynomials? You can do the box method. You can do the separation one that I taught you guys. Or you can just do regular FOIL method. Okay, distribution. It's up to you, but I think it's easier to visually see how to do this one. So the 2x plus 3 goes here because there's two terms. You could do it the other way too, but I prefer my square looking like this. Just make sure you're putting it on the correct box area. So that's 4x squared minus 5x plus 1, 2x plus 3. So each parenthesis should be on each one side of the box. So now let's multiply 4x squared. So first let's do 4 times 2. That is 8. X times x squared. That is how many x's? That's 3 x's. So that's x cubed, and then so on. 2x times negative 5x, negative 10x squared. 2x plus 1, that is 2x. This is 12x squared, negative 15x plus 3. And just combine like terms. Usually the like terms are across from each other, like this. So first step was to multiply using area model. Number 2 is to combine like terms. So that's 8x cubed. 12 minus 10 is 2x squared. Negative 15 plus 2, that's negative 13x plus 3. So that is your solution. All right. Number 25. For number 25, I'll modify one of the problems. I'll do H. Actually, no. I'll do B. So that's a squared plus 6a plus 9 equals 0. If it's a trinomial, we can factor using the x method. It's called the quadratic because it has a 2. And equals 0. This is probably going to be the part where most of you will forget. Please don't. Okay, I really want you guys to pass your test. So here's the first things first. Obviously, we're going to do our x method here. So it goes a times c, and this is b. My a equals 1. Here, let me roll it real quick. A equals 1. B equals 6, C equals 9. Okay, 1 times 9 is 9. And B goes down here, 6. So let's list out everything that multiplies to 9. So that is 9 equals 3 times 3. 9 equals 1 times 9. Which one of these two add up to 6? okay? Obviously, it is 3 plus 3, right? So our factors will be 3 plus 3. I'm sorry, not 3 plus 3, 2 times 3. So it'll be here, 3 and 3. Make sure you're using the correct variable here. So we're going to end up with a plus 3 equals 0. Remember, zeros of a polynomial, 0. So we're going to equal both to 0. But since they're the same number anyways, we're just going to do it with 1. AKA, a plus 3 equals 0. Subtract 3, a equals negative 3. And notice here that a equals 1. Make sure that if a is greater than 1, you divide by 1. Or you divide by whatever that number is. Okay? Let's do number, we got 21. Actually, no, it's number 22. Okay, for number 22, you are going to, so we are dividing polynomials. Sorry, dividing rational expressions. In this dividing rational expressions, you are going to keep the first fraction the same. So it's 1 over n plus 2. Change this into multiplication and then flip these two. So that's n squared plus 10n plus 9 over 4n plus 36. So now, remember on chapter 3.3, we are going to box each one with a plus or minus in between. There we go. I'm going to number them from 1 to 3. Can we factor number 1? Does n and 2 have a GCF? No. Now let's go to 2. We see that there's a square and there's 3 terms. So what are we going to do? We are going to factor using our X method. This is number 2. So my A is 1, my C is 9, so it's 9 up here. My B is 10. What multiplies to 9 adds up to 10. That is 1 and 9. So our factors would be n plus, well, do I have to divide? No, right, because my A is 1. So it's n plus 1, n plus 9. I'm going to replace this with n plus 1, n plus 9. How about these two? How about 4n plus 36? Can I factor this? Yes. There is a GCF of 4n and 36. Remember what multiplies to 4? 2 and 2. What multiplies to 36? 6 and 6. What multiplies to 6? We have 2 and 3 and 2 and 3. Alright, so 2 and 3 and 2 and 3. Two and 3. So what do they both have in common? They have a 2 in common, and they have another 2 in common. So what's left? So what does that mean? 2 times 2 would be 4, would be their GCF. What's left over in 4n? N is left over. And 3 times 3, 9 is left over. So I'm going to replace 4n plus 36 with 4n plus 9. So let's go ahead and rewrite this. 1 over n plus 2 times n plus 1, n plus 9 over 4 times n plus 9. What cancels out here? This cancels out, this cancels out. And we are left with n plus 1 over, so you would start with 4, These are together. You can put them in a box. So you put a parentheses around it. So that would be your solution there. To show your work here, just to justify, make sure you use a sentence or a few words just to show your step-by-step process. Okay, if you have any questions, ask them before we take the test on the day you will take the test. All right, if you have any questions, also shoot me an email, come after school to ask a quick question. All right, bye.